All right, so the diameter of cylinder is measured in as this, and calculate the absolute uncertainty. Okay, we could do that. So you just want to take 1.6% of 0.0125. So where is the calculator? Okay, here. 1.6 divided by 100 multiplied by 0.0125. That would be 2.0. No, just 2. 2 into 10 raised to power 1 to 3 minus 4. Okay. Now, why am I not writing 2.0? Because uncertainty is always in one significant figure. That's fine. Okay. Now, the cylinder in the stands a horizontal surface, and we want to calculate the pressure P. Okay. So the weight, where's the weight? Oh yeah, it's there. 0.38 divided by 5, and the diameter is 0.0125 whole square. So 4 into 2.38 divided by pi times 0.0125 and whole square. So this is 3100. Yeah. Okay. Then determine the absolute uncertainty in P. So to do that, I have to write delta P over P equals to delta W over W. We're going to ignore 4 because it's a constant. Delta D over D, and then we're going to multiply 2 here because of the power. So you write 3100, you write 2.8%. So you just write 2.8 divided by 100. You don't need to do anything else because percentage means already it's a fraction. And I hope that's in percentage too. Okay, 1.6. So 1.6 divided by 100. So easy. And now 2.8 divided by 100 plus 2 times 1.6 divided by 100 times 3100. That's equivalent to 186. Now, how would I write it? I would write 200, but that's that. Okay. And it should be one significant, then plus minus, and then 3100. So the decimal places in this answer is the same, so that's great. We get the answer. Now, state the second law of motion. Second law states that resultant force is rate of change of momentum. Please don't write F equals to MA, that's not the definition. Okay, so there's a tow bar, there's a trailer, and a mass, fine. And they have given a variation, that's great. Calculate the distance traveled, 0 to 10. So you're gonna go here. This makes it a trapezium. Oh, how clever they are, see? Now, one thing you should always notice is that this axis is not starting from 0, okay? This means that actually, this is not 1, this is actually 9. It starts from somewhere down, and that's 13. So 13 and 9. Don't take 1, okay? Please don't. And that's 10. So what you're going to do? Half times base times sum of parallel sides, and 0.5 times 10 times 9 plus 13. Okay. So that's 110. So we're going to write 110. And all of it should be written here. Please don't be lazy like me. Like that. And then at time t, the resistive force acting on the car due to A resistant friction is 510. The tension, the tow bar is 440. Calculate the acceleration. Right. Okay. So back to what they have shown. So the tension in the tow bar is 440. The resistance force is 510. and we got to find the acceleration at 10. Well, do we really need to use forces? I don't think so, right? We can just simply find the gradient. So we can take this value. This value will be 0 and 9. And this value will be 10 and 30. So taking the gradient, 9 minus 13, 0 minus 10. Divided by minus 10. So that is 0.4. Okay. Now, if you write 0.4, that's wrong. So you have to write at least 2 significant figures according to our, you see, all the data is, this is 2 significant, this is 2 significant, like that. Okay. Then use your answer to calculate the resultant force. So the resultant force will be F equals to MA. Now the mass was, I think, somewhere given 850. That means it is going to be 850 times 0.40. This would be somewhat like 340 newtons. Now, show that the horizontal force of 13 exerted on a car by engine. Right. So first of all, I would like to tell you that, okay, let me see. So there's a tension in the tow bar, and of course the car is pulling this. So we're looking at the car only. So when the car pulls this, so car feels the tension here as well. So that's 440. There's a resistance force, and it says you need to show the X3. Is there anything else? And show that the horizontal force of exerted on the car by the engine. Okay. Right. So we have the resultant force. So resultant force will be equal to engine force plus the tension plus the resistance, right? So this is 340. This is what we're looking for. By the way, these should be negatives because they're acting in the opposite direction. So that's 440, and that was 510. So the resultant force is going to be, we're going to add them all together. So that's 1290, which is approximately equal to 1300 newtons. This means short. All right, now determine the useful output of the car. Okay, so for power, we use this formula. We have the force from the engine as this, and the velocity has to be somewhere, at time 10 seconds, right? So at 10 seconds, the velocity is 13. So I'm going to take that and I'm going to multiply this here. So 1300 times 13 would be 16900. I would love to write it as 17000, but you can also get away with 169. All right. That's also conforms to the rules. Wow, this question is long. Now, a short time later, the car in B is traveling at constant speed and the tension tow bar is 480. The tow bar is solid metal rod by exhaust law, blah, blah, blah. Determine the extension. So extension is force times length over area times Young's modulus. The force they say is 480. The length is 0.848. Cross-sectional area is 3.0 times 10 raised to minus 4. And the Young modulus is 2.2 times 10 raised to 11. Let's do it. 3.0 times 10 raised to power minus 4 times 2.2 times 10 raised to power 11. Okay. That sounds very cool. So the extension is 1, 2, 3, 4, 5, 6. 3.5 times 10 raised to power minus 6 meters. So I think that should be the answer. Then it says the driver of the car sees a pedestrian standing directly ahead in the distance. The driver operates the horn from 15 to 17. Okay, first of all, we're going to check what is 15 to 17. 15 is here. This should be 17.5, somewhere here. So it doesn't really matter. At that time, the velocity is constant. That's great. So we have 14 velocity of the car. So source is 14. Now it says the frequency of frequency of the sound heard by pedestrians. So this is the observed frequency, and this is V, and the frequency of the sound. So observed frequency is Fs times V over V minus Vs. Why? Because it's moving towards the observer. Okay, so 480 Fs V 3. Oh no, this has to be 340. 340 minus 40. Right. So 480 times 340 minus 14. And then you got divided by 340. So that makes it 460 Hertz, and should be the correct answer. Now, if you have any questions, please let me know. All right. Okay, you guys got to give me 1 second. Okay. All right, so going to the next one. What is meant by the center of gravity? So center of gravity is defined as a point where all the weight of the body appears to act. Okay, so you can either write appears to act, or you can also write seem to act. So it should be written very important. All right, now then this question. Okay, seems very hard. Calculate the vertical component of the tension in the wire. So that would be 54 sine of 35. By the way, I just realized something just now. And that is, you have a math exam that day, and it is in the morning, right?
Yeah.
Now, when you go out of the math exam, make sure your calculator is in degree mode again.
Yeah, good point.
Yes, because I know in math they use radian a lot, and in physics it's not there. So you can get a lot of wrong answer. Even like I realized this, right? If you have radian mode, let me see what the answer it gives. Radian. Okay. So see, it gives you minus 23. That's wrong. So we should
That's so
always.
scary.
Yes. So you have to remember this, okay? Now, explain why the force on the sine B does not have a moment about point A. Sine B. Okay. There is no moment because the distance from the pivot is 0. The distance from the pivot of the force is 0. That's right. Okay. Now, by taking moments about point A, show that the weight of the sine is 150. Fine. So we have this pivot. The weight is right here. This means this distance, perpendicular one, it has to be 0.34 meters. And this is another force, which we found out, which has a perpendicular distance from the pivot as 0.68. Do we have another force? This force, which is 54 cos of 35. And the perpendicular distance from the pivot is also like this one, right? No, sorry. The perpendicular for this one has to be 0.6. Oh, they have the same distances on both sides. Okay, cool. Now, what I'm going to do is I'm going to check where they're going to turn. So about A, this is going to turn this way. This is going to turn this way. And this will also try to turn this way. Okay. So this seems anti-clockwise, anti-clockwise, clockwise. Let's do this. So clockwise equals to anti-clockwise. The clockwise force was W times 0.34. And that was 54, 31. 31 times 0.68 plus 54 cos 35. I think it was 35. Yeah, times 0.68. Okay. Now let's do this. 31 plus 54 cos of 35 times 0.68. Okay, divided by 0.34. So that goes to exactly 150 newtons. Sure. Wasn't that scary? Calculate the total vertical
Sir?
force. Yes.
Can you please show me what you wrote for point 2? Just 1 second.
Yeah. The distance from the pivot of the force. The distance from the pivot of the force
Yeah, I
is
don't
0.
get this. Could you explain, please?
If the force of the at B was like this, right? It's holding it
Yes, sir.
upright. So it's actually the line of action of A and B like this. So there's no perpendicular distance. If the force was somewhere here, then there was a perpendicular distance, right? Right now there isn't. You understand this?
No, sir.
The force is vertical, right? At this point. You see the line
Yes,
of
sir.
action, this dotted line that I'm making, right?
Yes.
If force acts exactly on A or its line of action, it means that it does not have any perpendicular distance. For moment, there has to be a force and then a perpendicular distance. Okay. Like this force is
Yes, sir.
also vertical, but its line of action is here. So it has a perpendicular distance like this. Do you understand? But if this force was acting, imagine here, then it would cause no moment because it has no perpendicular distance.
Right. Okay. Thank you.
No worries. अच्छा, उसके बाद कहता है calculate the total vertical force. So there's one vertical force, 31 newtons that we found out, and there's 150. There's no other vertical force. This is horizontal, so it should be 150 minus 31. We're the opposite direction. So let's do it. That's 119. You can also get away with writing 120. Okay. So it falls from rest, initial velocity 0, and through a distance displacement. The nut lands on the pavement with the speed of this. The final velocity, determine for the falling nut from the sign pavement the ratio. Right. Okay. Do they have they? No. Okay. Very clever people. They haven't given us the mass, but we are cleverer. So we're going to write this, and then we're going to write this, and then we will cancel this out. Yes. And then I'm going to write 9.81. Then I'm going to write the distance, and then I'm going to write half and the velocity, which is the final one, squared. Now let's do this. 0.5 times 9.2 whole square. So that is 1.1. Any questions, please let me know. Now, question number 4. This is my favorite part of the paper. I love waves. The progressive order waves state what is meant by displacement. So displacement is in waves particularly distance with a direction. But now you're to write one, and the second point should always be from the equilibrium. Because waves oscillate up and down or back and forth, right? So they have an equilibrium. What is an amplitude? So that's the maximum displacement 1 second from the equilibrium. Equilibrium. Okay. Now, all right. The phase difference between the waves are 180. Wave X has an amplitude 1.2 and intensity I. Wave Y has an amplitude of this. Calculate in terms of intensity the resultant. Calculate in terms of intensity the resultant intensity of the meeting point. Well, we could do this. I mean, one wave is like this, the other wave is like this. Okay? They're like anti-phase to each other. Suppose that this was 3.6 and this was minus 1.2. So the net amplitude would be equal to 3.6 minus 1.2. That would be 2.4 centimeters. Okay, now, because now it's asking about the ratio, the intensity of 1.2 was I, right? So I'm going to write I1 over I2 equals to A1 square over A2 square. This is the ratio. Whenever he asks about any ratios, please do use this. Now, I1 was just I. I2 is what we're looking for. A1 was 1.2 whole square, and the new displacement, the resultant was 2.4 whole square. Now, let's do this. So 2.4 whole square divided by 1.2 whole square. So this will be 4 times I equals to I2. I switched the places, by the way. If you're confused why I just took 2.4 on top, because I want to make I2 the subject. That's why. So it should be 4. And now don't just write 4, write 4.0 I, like that. Monochromatic light is incident on a different. Yes.
Do you always subtract them, the amplitudes?
No. If this was like 0 degree or 360 degrees, right? Then
Yeah.
I would, because both would be like this.
Okay.
180 means that this is destructive interference. Monochromatic. Monochromatic means light of single frequency, okay? If you don't know. And on diffraction grating, describe the diffraction of light waves as they pass through the grating. Okay, so they're just talking about diffraction. Okay, so diffraction definition is that when waves pass through a slit, they spread into geometric shadow. That's the definition of diffraction. Now, the moment you hear diffraction and diffraction grating, or so you definitely just write d sine theta equals to n lambda. Now they say parallel beam of wavelength. So we have the lambda and we have the lambda here as well. So there are two of them. The light is incident. Third order diffraction maxima is produced for each of the two wavelengths. No higher orders are produced. Okay. Determine the smallest possible line spacing. Smallest possible line spacing, D. Oh, interesting. Third order, right. Smallest possible line spacing for two amongst these. Let me think. So we got D. Unfortunately, for some reason, because the maximum diffraction is produced when theta is 90. So we're going to put 90 here. N is the third order, we got the lambda. And now which lambda to choose? This is the important question. If I think about it this way, the greater the wavelength, the larger the theta. If the theta is there, the larger wavelength would produce greater diffraction. So this means I should be using this wave, not this. So let's try. 630 times 10 raised to power minus 9. Sine 90 is 1, by the way. 3 times 630 times 10 raised to power minus 9. So D here would be 1, 2, 3, 4, 5, 6. 1.9 times 10 raised to power minus 6 meters. Okay, please do check the answer, okay? So because I'm not sure if that is the correct answer.
Yeah, it is.
Okay, that's good.
Yeah. Sir, for the smallest line spacing, you take the biggest wavelength.
Smallest line spacing, I used it because you see, you need to understand that the greater the wavelength is, the greater the diffraction is, right?
Yeah.
So you have to check this one because if the line spacing is more, like this is more, right?
Yeah.
Then this, it would have greater angle as well of diffraction. Means it will go out of the like diffraction grating. The maximum diffraction can only be at 90 degrees, okay? It's like this. Okay? Now, you don't want the wave, this one, to go out, right? Because you can't go out like this. So you have to check on the largest possible wavelengths. What would be the minimum D unit? Okay, do you understand?
Yeah.
All right. Now the beam of light in C2 is replaced by beam of blue light incident on same diffraction grating. Beam of light in C2, where is C2? Okay. Is replaced by beam of blue light, same. State and explain whether third order. Now, this is something you need to basically understand. And that is these wavelengths that they've shown, right? So you should remember that 400 nanometer is violet and 700 nanometer is red. Okay, so this basically lies, this one must lie in orange, reddish orange, and this should lie somewhere in the middle. That should be probably like green. Okay, so more than green, like yellow probably, right? Now, if blue light is there, so blue is a shorter wavelength. Okay. If blue is shorter wavelength, then it would diffract less. Diffract less means that it will have more orders then, because it is short wavelength, right? So we are going to write this. So wavelength of blue is less than 540 nanometer, right? Or 630, doesn't matter, whatever you write. Hence, it would diffract less. This means it will have more orders, a larger order than 3 if you want to write it. Now, if sometimes you get confused and you're like, what do I do? So you write the formula and then you're comparing orders with lambda, right? So you can divide lambda here, now orders. So they're inversely proportional. The greater the lambda is, the less the orders it's going to create. If the lambda is smaller, like in our case, then there will be more orders. Do you understand? Everybody, please do let me know if you have a question here. All right. Now this was a difficult question. This wasn't easy. I thought it should be easy. Now, state
Sir?
the.
Sir,
Yes.
I'm sorry I have to leave right now, but do we have a class tomorrow? I'll go through the recording later, but I just wanted to ask this.
Yes, 11 p.m. Pakistan.
Okay, thank you.
All right, bye. Now, electricity. Now here, Kirchhoff's second law states sum of EMFs is equal to sum of potential differences in a closed loop. That should be written. Now, they have this. The combined resistance of two resistors connected in parallel. This is super easy. So you just do this and then put it equal to 1 upon R. So you say 1 upon 90 plus 1 upon 18 and then 1 upon answer. Why? Because I have to take the reciprocal of R, right? So that's 15 ohms. 15 is 15. Okay, so 15 is already 2 significance. That's great. Now the current in the battery. Okay, so the reading on the voltmeter is 4.8. So that's the terminal potential, if you know. Now the equation is EMF equals to terminal potential plus the voltage loss. So the current in the battery, well, we don't need this. We don't have voltage loss, right? Because R is not given. Well, so we could just use V equals to IR. We have the potential that is 4.8. We need current and the resistance outside is 15. So that should be 0.32 amperes. Pretty good. Now show the internal resistance is this. Okay. There are a couple of ways of doing this. You can always write terminal potential plus voltage loss. The EMF was 5.6. The terminal potential was 4.8 and the voltage loss is current into internal resistance. So 5.6 minus 4.8 is 0.8 equals to IR and I will be 0.8 divided by the current. So that would be 2.5. Okay, they just have to show it. Sure. Now, ratio of power dissipated and total power produced by the battery. Okay. So power is VI over VI. The voltage in the internal resistance was actually 0.8. Why? Because if you subtract the terminal potential, you get voltage loss. Okay. So you write 0.8 times the current, which was 3.2. And then the battery was 5.6 times 0.3. Okay. So let's do it. Let's try. Gets the right answer. 0.3. 5.6 times 0.3. Okay, so this is 0.14. 0.14. Pretty simple. And now you could, oh wow, determine the current in the circuit. Now, whenever this question comes, you can always pick, from any point. If I were you, I would always pick the larger battery. So the current, if it goes, this is the positive terminal, so it goes here, right? And this is my loop then. Okay, so I'm following this loop. This is my current. If you don't notice, this is positive and a positive terminal is connected here, which means these two batteries are opposite. So what I'm going to do, sum of EMFs are going to be 7.2 minus 5.6 because that's opposite. And sum of potential differences are going to be current times 3.5 plus current times 2.5. So what you're going to do? 7.2 minus 5.6 is 1.6. 3.5 plus 2.5 is 6 I. So 1.6 divided by 6 is 0.27 amperes. If you have any questions, please let me know. Okay, so electric field is out of our course, so we're not going to do that. And that's it. Well, we could do this. Why not? We could wait. What is this question? Magnitude of acceleration. Yeah, okay. We could only do this. Particle P is a hadron composed of two quarks. Okay, so this is he's talking about meson. Okay. One of them is a down quark. By considering the charge, determine possible flavor of the other quark, explain your working. So what is particle P? That's what we need. Particle P has a mass and -1 is the charge. Okay. Down is already -1 by 3e, and you've got to add -2 by 3e, so it should give us like -1e. -2 by 3 is an antiparticle, so you could take up, you could take top, you could take charge, any one of these. Okay, so up, dash, and d. So that should be the answer. Okay. You guys have any questions? Please let me know.
No, sir. So which paper do we do tomorrow?
Okay, so tomorrow we have